We are solving equations today. Remember, the concept of an equation is that both sides of the equal sign always have to stay balanced with the same value. So all we're going to use today is addition and subtraction when solving our equations. Now, the one key concept here is inverse operations. So when we take a look at this equation, we know that this side has to equal 10 because this side equals 10. Now, we can use some mental math, but what I want to show you today is how we actually go about solving an equation if we're going to do it algebraically. So I look at this and I can think to myself, all right, I know if this side has to equal 10, x is probably 6. So I have an idea of what my answer is going to be. So let's go ahead and solve this. Now, the way that you solve an equation algebraically is you always start on the side that has the variable. And our job is to get that variable by itself, which means we need to get rid of this plus 4. And the way you get rid of plus 4 is you use the inverse operation of addition, which is subtraction. So here I'm going to subtract 4 from this side, but the moment I subtracted that 4, I went out of balance with my equation, and I'm never allowed to be out of balance. So in order to pull myself back into balance again, I need to subtract the exact same amount from the other side. We say whatever you do to one side, you have to do to the other. As long as you're subtracting the same figure from both sides, then you're always going to stay in balance. Well, when you use inverse operations, it means that those numbers cancel each other out. They go back to 0 because they're on opposite sides of 0, equal distance away. So all that I have left on this side of the equation now is x, and we know 10 minus 4 is 6. And I thought 6 should be the answer. Now, the beauty of algebra is we can always check our answers. If I think x is 6, all I need to do is go and plug 6 back into the original equation. And if that side is equal to the other side, I know that's a correct answer. Now we can also do it with subtraction. So again, we're going to start on the side that has the variable. I look at this side and I know that it has to equal 6, so this side has to equal 6. Well, I can assume that u is going to be 9 for that. So when I go to do it, I have a general idea of what my answer is going to be, but remember, we're focused on solving algebraically. So start on the side that has the variable. I need to get the variable by itself, so I need to get rid of this minus 3. How do I get rid of minus 3? Well, I use inverse operations. So the inverse of subtraction is addition. Uh-oh, the second I added 3, I'm out of balance. And I can't ever be out of balance. So in order to pull myself back into balance again, I have to do the exact same thing on the other side. Whatever I do to one side, I have to do to the other. Now the inverse operations cancel each other out. I'm left with u, and 6 plus 3 is 9. And again, we can check it by plugging 9 into the original. And if that side is equal to the other side, I know it's a correct solution. Now, sometimes you have to gather some terms before you actually go and do your inverse operations. So notice, with my variable, I always have just one other number with it. Well, if I had something that looked like this, well, I need to pull my like terms together. So we know that 3 and 6 are both constants. So before I even begin to solve, I need to pull those two together. So when I pull those together, I get 9. So I have c plus 9 equals negative 9, and we can have negatives here as well. So I know I'm going to start on the side that has the variable. My inverse operation of addition is subtraction. Whatever I do to one side, I have to do to the other. Now, this was a negative 9, and sometimes it's hard for us to see exactly what's going on with those integers. So remember, whenever you're subtracting, you can rewrite it as plus the opposite. So now I can see I have 9 negatives and another 9 negatives that are coming together. That means I have negative 18. And when I go and I plug it back in, I can see both sides equal -9, therefore it has to be correct. So be careful when you're working with these negative integers. Always rewrite a subtraction to plus the opposite, just so you can see whether that integer is a positive or a negative. Now we can also do it when we have two constants over on this side. So I have to pull these two together, but notice I have minus. Okay, I want to see it correctly, so I'm going to change that subtraction to plus the opposite. So now I can see that that's clearly a -7. Now, I can't easily take an inverse when I have plus and negative. So if you switch those subtraction signs to plus the opposite, before you go to solve that equation, switch it back. So remember that plus can become a minus, that negative can become a positive. So once you have it in a form that is just an addition or a subtraction of a positive number, then it's a lot easier for me to take the inverse operation for that. So when I take that inverse operation, I can see n equals 12. Always do your check, because your check is going to tell you whether you did, whether your solution is correct or incorrect for that. So that is solving equations using addition and subtraction. It's always inverse operations. Whatever you do to one side, you have to do to the other. Good luck.